After the god-awful nightmare of the previous problem, let's do something a little bit easier here. 2012, problem 2. All they're asking us to design here is an experiment to, given a list, mechanical energy involving a transformation from initial gravitational potential energy to translational kinetic energy. So they just want us to design an experiment. The first thing we need to do is we need to pick out some pieces of equipment. If you're really, really quick on this, watch, look, I can spell stick. I can spell stick real well. If you're really, really quick on this, and we've done a couple examples of these over the course of the year, all we really need is a meter stick and a stopwatch. As long as you say meter stick and stopwatch, you're in good shape for this whole thing. Okay? That's what they're looking for. Outline a procedure for performing the experiment, include a diagram. Okay. What I have here is I have a mass on top of some wheels, on top of a table, flat table. I've got some hanging mass here, so M1 and M2, okay? We remind ourselves that this guy's got all the gravitational kinetic energy. I'm kind of jumping around here a little bit. So that's going to be M2GH is equal to, and then when the whole system is moving, both of them have kinetic energy. So I've got 1/2 M1V squared plus 1/2 M2V squared. Those V's are going to be equal. I'm going to use the stopwatch and the height to find the velocity, and if I measure the height with the meter stick, then I should be able to figure out the relationship between gravitational potential energy and kinetic energy finally, okay? So what they're looking for is a detailed procedure. I've kind of done it here, and then they'll give a detailed account of the calculations of gravitational and translational kinetic energy. That's this guy right here. So they're really just asking for you to design an experiment, and you're going to use words. Now please make sure, whenever you're answering a question on the AP and they're asking you to use a lot of words, don't repeat yourself over and over again. Don't panic and think that writing down a whole lot is going to get you the right answer. You want to be short, quick, and concise. Use a stopwatch and height to find the velocity, measure the height, measure M1 and M2 using an electronic scale, bada bing, bada boom, you're good there. According to AP Central, they are actually going to be asking you guys to design an experiment this year. So you should be ready and thinking about what kind of material you would need and what principles you might be trying to figure out. Okay, in part D, after your first trial, your calculations show that the energy increased during the experiment. Assuming you made no mathematical errors, give a reasonable explanation. My reasonable explanation would be either you accidentally gave a push to M1, so instead of your partner releasing M1, they might have just given it a little bit of push, so they gave it an initial velocity, or maybe the table is not completely level, so you have a little bit more force that is acting on the object. That could be throwing off your calculations a little bit because M1 is actually going down a little bit. Okay, so those are two possible answers. And then E, on all your trials, your calculations show that energy decreased. Friction. If there's friction inside of this pulley, then that means that you are going to lose some energy. Okay? Read through this one. I kind of sped through it real quick because I just don't find these to be very interesting. I think designing the experiment is very straightforward. Read through this example and you should be ready for one like this on the AP. Just think about the material that you would need, think about the principle you're trying to prove, and think about possible sources of error. It is very straightforward.